Are we just going to finish this one, or are we going to
Yeah.
do the, and that's it?
Just finish that. All right, welcome back. We're going to continue on and look at some details of testes epididymis. Testes, IS is singular, ES is plural. There it is, right there, and it's a simple structure to look at. It's the gonad. And the epididymis is right on top of it. I guess one thing I didn't know before was that the epididymis has head, body, tail. Epididymis, that's D-I-D-Y-M-I-S, epididymis, overlies testes. It has head, body, tail, which you are responsible for. Now, it's a coiled tube. It's about 20 feet long. And then there's the histology of it. Feet in length. And think of it as a space for storage of sperm. Stored spermatocytes are there. There is a bit of maturation that goes on. Sperm, they develop their motility a little better. Okay. In sperm, we always draw them like this, right? We consider, in terms of a fertile male, one is motility. Can they swim? That's one thing you look at if you're examining, testing for fertility in a man. You look for morphology. Do they have that characteristic head, body, tail, rocket shape? You look for numbers, of course. You should have something like 100,000, in the hundreds of thousands per mil. Okay. We always say you only need one to fertilize, but you do need those hundreds of thousands because there's a lot of attrition after ejaculation and to get enough to fertilize the egg. So the epididymis, if you look at it under the microscope, you can see the sperm, the spermatocytes in the lumen of the epididymis. They look like a bunch of tubes. So really, it's one continuous tube. Because if it's all coiled in there and you make one cut through it, I mean, you're cutting one tube in a bunch of different locations, so it looks like many tubes. And if this is a low mag, if you look at it under 400x, what you should be able to notice are the spermatocytes. Notice that you have, again, a pseudostratified epithelial tissue with stereocilia, lined with a pseudostratified ET with stereocilia. Remember, this is also in your histology class, and we do want you to know the tissue types here.
I'm sorry, what's ET?
Epithelial tissue. And that is, well, look at here. That's the basement membrane. All epithelial tissues overlie a basement membrane. There's no smooth muscle, okay, like there was in the vas deferens. And, well, that's an important detail, because if you look at the two slides side by side, if you just put one lumen against another, They both have spermatocytes. How do you tell what's what? They both have similar-ish epithelium. I always look for the many layers of smooth muscle. Okay, this is not smooth muscle, it's just connective tissue. So that is one way you can tell or not confuse epididymis with ductus deferens. You are responsible to know both. Let's talk about some details of the penis. I want you to know how the root of the penis is attached to the pelvis. So I have a picture of a pelvis here. This happens to be a female pelvis, but it's a figure that shows these two muscles that I want you to know. This is a figure showing you just kind of skin, and they show you the pelvis inside it, and they show you this kind of diamond-shaped region. This region is called the perineum. Perineum is a region of the body. I define it as the area between thighs and buttocks. They always kind of draw that shape to approximate the perineum. This triangle part is the UG triangle, or well, the UG stands for urogenital, right? Anal triangle. Although they didn't draw it as a triangle, they draw it as a half circle, but it's usually called the anal triangle. Sometimes books draw it like, you know, like this, not like a half circle. It just depends on the book. But anyways, those two triangles or half circle, that's the perineum. Okay. This is like kind of shaped like a bike seat, right? You know, when you sit on a bike, that's the perineum. That's what your bike is sitting on. In fact, I've even read that professional bike riders, they have a problem with blood supply to their external genitalia, because that bike seat is always impinging the blood vessels to their external genitalia. This is the UG diaphragm, which I had mentioned before. So distinguish the triangle, which is just the area, versus the actual UG diaphragm. And then what we had noted before was that the urogenital diaphragm, or UG, the muscle of that diaphragm is the deep transverse perineum. We colored it before. But there's also superficial transverse perineal. So I'll point it out on the picture here. That's the deep one. We can see why it's called transverse, because it's in the transverse plane from there to there. And this one, the superficial, is a band, and it's right on top of it. Okay. This is the pubic arch, and this diaphragm, it kind of expands the width of the pubic arch in males and in females. If you go back to the coloring plate, I think, what was that? This one. The deep transverse perineal on this picture right in here. It's deep. And they put a bunch of muscle fibers running in the transverse plane, right like that. Okay. It's also right here. Still make it out. That's the deep one. The superficial one, I'll color in blue. It's right here. Now it's kind of hard to tell in the coloring plate that it's deep versus superficial, but it is, and the models will show it a little better. Okay, when you study this. Anyways, deep and superficial. Now I mentioned that because the penis is kind of right there. The root of the penis is attached to those things. So I'm going to fast forward back to where it was. I was right here. I was here, next slide, boom, here. So now you can see how the root of the penis is right on top of this area here, the deep transverse perineal. Superficial is not shown, but there's deep transverse perineal right there. And we can see the erector muscles here. Bulbal spongiosis over the bulb of the penis, and this is the ischiocavernosus. If you remove it, you see the crust of the penis. So you have crust of the penis on this side and on this side. The crust is attached to the ischiopubic ramus. Let me write that down. So the penis is root shaft. The root's the part you can't see attached to the pelvis. So the root, you have crust. Remember, the crust means legs. These are the legs of the corpus cavernosum, those paired dorsal bodies. Quote unquote legs. Crest means legs. Pair legs of corpus cavernosum. The crusts are attached to the ischiopubic rami of the pelvis. That's the bony structure that they're attached to. And let's remember that the crusts are wrapped with ischiocavernosus muscle. Those are the things you can see on that slide. Okay? The bulb of the penis, also considered the root, is attached to the deep transverse perineal. I'll just say, yeah, attached to, yeah, let me say that, attached to. And it's wrapped with, the name of that erector muscle is bulbal spongiosis. You can see from this picture also that the two erectile bodies can be separated. I've done this dissection once, and it's hard to separate the erectile bodies. I have to use a scalpel to get the glans penis off. The other thing we can see is that the corpus spongiosum forms the bulb proximally in the root, but it forms the glans penis distally. Okay, so this is all considered corpus spongiosum. Write that down. So corpus spongiosum forms glans penis distally and bulb proximally. And the bulb of penis proximally. So those are two different things, bulb and glans penis, but they are both basically that erectile body, corpus spongiosum. What you can see is that the paradorsal bodies, the corpus cavernosum, it diverges at the root to get the two crusts. The two, the pair dorsal bodies diverge at the root. Forming the crust of penis. The legs, okay, one on each side. So here the paired bodies are together, but as you get more to the root, they kind of diverge. One goes off one side to the other to attach to the pelvis. So that if you look at a full-on labeled picture there, okay, I just kind of put some of those notes there. So I put that already on the board. However, it's interesting to note these two erectile bodies, they both become engorged with blood. The corpus spongiosum remains relatively soft during erection. It's the corpus cavernosum that becomes harder during erection. That's because you don't want to completely squeeze the urethra that's inside there. Okay, but it still does engorge with blood. To make a cross-sectional view, you get a different picture if you cut through the root versus the shaft. Okay? And so if you cut through the shaft, you get this view here. You should recognize the erectile bodies. There's a little bit of a deep penile artery there. This is the corpus cavernosum. And this is the singular corpus spongiosum. If you cut through the root, you can see that the paired corpus cavernosum are wrapped with tissue cavernosus. You can see that the spongy urethra is surrounded by corpus spongiosum, and that is wrapped with bulbal spongiosus muscle. Okay, that's why I wanted to show this. You don't see the erector muscles here because that's the shaft, but you see them here because at the root, that's where those erector muscles are. And you can also see this muscle here, the deep transverse perineal. So they kind of call this view the monkey face. Resembles that, I guess. But the paradorsal bodies is your corpus cavernosum. You can see that there's a membrane between them. So they're definitely paired and separated. And there's the corpus spongiosum. This emphasizes dorsal veins. Dorsal penile veins, they become compressed during erection, and that impedes blood flow out. So that helps maintain the erection. Impedes blood flow out. That helps maintain erection. The histology picture I took, I rotated it in a way so it looks like the monkey face, the paired corpus cavernosum. So this pinkish tissue that surrounds the lumen is the corpus spongiosum, but we can see that the lumen is the urethra, the spongy urethra, and you can even see the epithelium that lines the lumen of the urethra that I want you to know. So I took a close-up picture of the epithelium that lines spongy urethra. It is a transitional epithelium, so let's note that. So let's remember, the corpus spongiosum contains spongy urethra, and that it is lined with a transitional epithelium. That's that. It kind of looks like a stratified cuboidal. Histologists thought that that this was a transition from stratified cuboidal to stratified columnar, but the name transitional just stuck. Transitional epithelium. I think what you can notice is this lumen, it has to accommodate urine or semen passing through, so it has an ability to stretch out. Okay, so you can stretch this thin, and it just has an ability to stretch with the added volume that's passing through the lumen. All right, so let's it's kind of a review. Let's kind of track sperm as it swims through the entire male duct system. You remember at the start of this lecture, I gave you the acronym 7-UP for those structures, and well, there's some details that were left out that you're responsible for, and so I want to take you through that real quick. So the male duct system, it starts with the sperm that develop in the testes inside the seminiferous tubules. The lobules contain seminiferous tubules. So here's a picture of the seminiferous tubules, and I'll tell you how they develop in another lecture. There's a lot of details on meiosis and spermatogenesis, as it's called, but we know that testosterone helps it. What you can see here is just isolating the tube structures that the sperm swim through. Starting with seminiferous tubules, right there. There's a bunch of them. And they all converge onto this net-like set of tubes called the rete testes. Sperm swim out of the rete testes through efferent ductules, several of them right here, each that go to the head of the epididymis. now we're in epididymis. The structure that overlies the testes. And we know that it's 20 feet long, but when it's all coiled up, be able to recognize head, body, tail. Sperm must swim all the way through down there, that's the tail. Then it continues on as Ductus deferens. Now we're going to start to go up the spermatochord. Okay, so I'll put in spermatochord. So it is side by side, the isolated ducts versus all the other structures that are in the testes epididymis. And actually, Ductus deferens is where a male is sterilized, typically called a vasectomy. Well, anyways, look at the picture, it's easy to understand. You just cut and ligate, right? Cut, ligate means tie off. So a man is sterile. You can reverse it, but this should be effective. So the ejaculate would just not contain sperm. Okay. Now to continue on, the ductus deferens will go through the inguinal canal. Remember, you end up here. This is the urinary bladder. So when you go over the ureter, the ductus deferens widens out. Remember I said that was called the ampulla of ductus deferens? So I'll put that next. Ampulla of ductus deferens. That is posterior bladder. So these structures are labeled, but what I want you to know now is when you get to the ampulla, you have to now pierce the prostate. So here's a picture of a model. There's the prostate. There's the ampulla of ductus deferens. It's right next to the seminal vesicle, which I'll get to. That's one of the structures that helps secrete seminal fluids. But the ductus deferens has the sperm, which is the most important contribution of semen. So I'll put this picture next to this picture. I like this picture, how they kind of cut through so you can see the open, complete urethra. Because when you get to the ampulla of ductus deferens, for the prostate, to go into the prostate, you have ejaculatory duct. To get to the urethra, which is next. And I like the picture on the right because it's easy for students to see that the urethra is shared by semen and urine, because the urinary bladder is right up there. I mean, not at the same time. Urine, semen. Both use urethra to exit the body. And the body does a very good job to make sure urine and semen never mix. For example, when you urinate, voiding your bladder is a parasympathetic response. However, ejaculation is a sympathetic response. So it's like they would never happen at the same time. And in fact, when you ejaculate, there's sphincters that will tighten right here, ensuring that you trap any urine that's in the bladder. It stays there during ejaculation. So we don't worry about them mixing unless there's some pathology or something. Okay. We can also see that there's three parts of the urethra, which I noted earlier: prostatic, membranous, spongy urethra. Prostatic, membranous, as well as spongy urethra. I'll just put prostatic, membranous, spongy because it says under urethra. And the orifice, which actually exits the body, is called the external urethral orifice. It's at the very bottom there. External urethral orifice. And that's the male duct system. So that's a lot of structures that we named that sperm have to kind of journey through emission and ejaculation. This picture points to the ejaculatory duct in two locations. Well, in the same location, just two different views, I should say. Here's the prostate. So if you point right there, that would be the orifice of ejaculatory duct in this picture there. Okay. So be able to identify the ejaculatory duct. Now, in terms of semen, the sperm need a lot of help. They have a long journey to go if they're going to fertilize an egg in a reproductively mature female. So there are accessory glands that contribute to the semen volume in this male duct system. And the word accessory means it's not a part of the duct system, but it secretes something into it. Basically, each accessory gland will secrete into some part of the urethra. So I'm writing accessory glands secrete seminal fluids into the urethra. Ejaculate may contain 3 to 5 milliliters, and each of these accessory glands will go through, contributes to some of that semen volume. So typical ejaculate, about 3 to 5 ml. Okay, so the first one I have, there's 3. This is 1, 2, 3. I start with the prostate right there. Prostate cancer is the #1 form of cancer in men. You can examine it, but it tends to enlarge with age. The prostate, when it's healthy, it's described as fibromuscular because it can contract as well as secrete. Its secretions add up to about 1/3 of the semen volume, and it's like a milky acidic fluid containing the citrate for the citric acid cycle for cell metabolism. But I think citric acid is its main contributor for the sperm, because the sperm they got to survive outside the body, right? They got to swim and fertilize the egg in the female reproductive tract. And citric acid the cell can use for its metabolism, but that makes the secretions of it slightly acidic. There's the citric acid cycle in all cells, right? We'll be able to identify prostate as well. The seminal vesicles are the largest of the accessory glands. They contribute most of the semen volume, about 60%. Seminal vesicle. Notice how they're right next to the ampulla of ductus deferens. So they're going to share that ejaculatory duct. I'll just put EJ for short. That's a typical abbreviation for ejaculatory duct. But please write that one out on a lab practical. Ejaculatory duct. So its secretion is alkaline. Basic. Now, you want to kind of balance out the acidity of the prostatic secretions. So let's think about this. We want to be secreted into the urethra. The prostate conveniently can just secrete right into the prostatic urethra, right? Secrete into prostatic urethra. The seminal vesicle too, because it shares the ejaculatory duct, its secretion will enter prostatic urethra. The Cowper's gland, or the bulbourethral gland, is a small pea-sized gland right there, and its duct will secrete right into the spongy urethra. Okay. So this is called bulbourethral gland. Its secretion is clear. It's a very small volume. It's alkaline. It may precede the other secretions. And its job is to kind of neutralize trace urine that may be in the spongy urethra. So all right, clear alkaline fluid neutralizes trace urine. So one ejaculation, so let me read where I'm reading from. I said 3 to 5 ml, so 2 to 5, 3 to 5, ballpark, it's about that much. One ejaculation may contain something like 20 to 100 million sperm per milliliter. Okay, so that's kind of the 20 is like the low end of the normal range for a fertile man. And we have all of these things that are in the ejaculate, like citrate. There's other things like prostaglandins that can actually make the smooth muscle of the female to contract. Ejaculation will deposit the seminal fluids right there. Fertilization would occur here. So along the way, all of these secretions will help it on its journey. It helps the female reproductive structures contract to kind of wash it up, the uterine cavity, to kind of get it into the oviduct here. Also, there's substances that increase sperm motility. Overall, the fluid is alkaline. There's even antibacterial things. And fibrinolysin, which helps free the sperm from the sticky semen, so it can actually swim to the egg. Okay. All right, done. Have a great weekend. We'll start with female repro.